morning. This is the second lecture of properties of pure substance. Okay. Right. First of all, I will define in this section Dryness fraction. This is denoted by X. This is very important terms. So okay, this is, let us suppose this is temperature, enthalpy, we have already discussed the different zones. So in this zone, this is wet zone. In wet zone, there will be combination of liquid and vapor. Let us suppose this is our point of discussion. This is point, okay. Let us suppose this is point 1. Just I'm going to discuss the dryness fraction at point 1. So in wet zone, we know that it basically comprises of two parts. This is liquid part and vapor part. Let us suppose the mass of liquid part is MF, where F stands for fluid, and mass of vapor part is equal to mg. G stands for, so F stands for fluid and G stands for gas, because of course vapor is just, it is the form of gas. So this is vapor. If MF and MC are the mass of liquid part and vapor part respectively, then dryness fraction X is equal to mass of vapor part divided mass of liquid part plus mass of vapor part. This is called dryness fraction. So this is the ratio of mass of vapor. So this is mass of vapor to the total mass of mixture, right? So this is all about the dryness fraction. So we need to understand what is the value of the dryness fraction at different point. Suppose that this is the, suppose that this is the point, okay. This point basically this lies on saturated liquid curve. So at saturated liquid curve, as you know, the mass of liquid only mass of liquid will be in mixture. In this condition, the mass of vapor, this is mass of this mg. In this condition, the mass of vapor will be vapor will be 0. So therefore at saturated liquid curve, the Dryness fraction will be, this is 0 divided mass of liquid plus 0. So this will be 0. So it can be said that therefore X at saturated liquid curve will be 0. This is one important observation of regarding Dryness fraction. Okay. Similarly, this is our next point. Okay, this point lies on this is saturated vapor curve. Okay, so this point lies on saturated vapor curve. So I want to find the Dryness fraction at saturated vapor curve. I have to find, that means at saturated vapor curve, only vapor part will exist. This implies in this condition the mass of liquid will be 0. So mass of mixture, which is equal to mass of liquid plus mass of gas, or it can be denoted mm by mg. So in this condition, the mass of fluid will be 0. This is mass of gas. So in this condition, mass of mixture will be equal to mass of gas. So if I have to find the Dryness fraction at saturated vapor curve, this will be equal to, as you know, this is equal to mass of vapor divided mass of liquid plus mass of vapor. At this point, this mass of vapor is equal to 0 plus mass of vapor. This is equal to 1. This implies the dryness fraction at saturated vapor curve will be equal to 1. This is our next observation. So basically what we observe here, the dryness fraction, so we observe here the dryness fraction always lying between 0 to 1. 0 to 1. This is the range of dryness fraction. In this condition, the x will be 0 at saturated liquid curve, x this x will be lying 0 to 1 in wet zone, and this x will be equal to 1 at saturated vapor curve. Okay, so this is very important. We need to understand what is the limiting value of this dryness fraction. This dryness fraction, the value of dryness fraction will be lying between 0 to 1. So at the saturated liquid curve, as we know that there is no vapor part, only liquid part exists. Therefore, in this condition, if you put the value of mf and mg in this equation, we will get that the dryness fraction will be 0. So it can be said that the dryness fraction at saturated liquid curve will be equal to 0. So if you move from left to right, that if you move from the saturated curve in right direction, so this wet zone starts. So in this wet zone, the value of x will be increasing from 0, and the maximum value of x will be equal to 1. So at saturated vapor curve, as we know that only vapor part exists, there is no liquid part. So if you put the value of this mass of liquid and mass of vapor in the equation of this dryness fraction, we will get this dryness fraction is equal to 1. So finally, the dryness fraction will be lying between 0 to 1, where this dryness fraction will be 0 at saturated liquid curve. Dryness fraction will be lying between 0 to 1 in wet zone, and this dryness fraction will be 1 at saturated vapor curve. This is important discussion about the dryness fraction, right? So this is very important discussion. We need to understand about the dryness fraction. Now we'll try to understand the properties, different properties of pure substance. So we will start the specific volume of mixture of liquid and vapor. So this basically the liquid and vapor will exist in wet zone. So this is the wet zone, okay? This is wet zone. In this zone, so let us suppose this is point 1. This is point 1. I want to find the specific volume of mixture at point 1. We need to find, let us suppose, this is volume of mixture at point 1 is equal to V1. This specific volume, this is specific volume, so this will be sine of a small v, right? So we need to find, I am just trying to calculate the specific volume of mixture at point 1, right? So let us suppose this is container. This container, since at point 1, basically it consists of this liquid part and vapor parts. So the liquid parts will be in bottom and this vapor part will be in this zone. Let us suppose this is vapor part, this is vapor part, this is liquid part, right? Vapor part and liquid part. This is in vapor part. Let us suppose this mass of vapor part is mg and volume of liquid part is Vg. Similarly, for liquid part, mass of liquid part is mf and volume of liquid part is Vf, right? So in this condition, since this defines the condition 1, the state of this mixture at point 1, since this is in a wet zone, this will consist of basically liquid and vapor. So this is the liquid parts, this is the liquid part and this is the vapor part. For the vapor part, the mg is the mass of vapor and Vg is the volume vapor. Mf is the mass of liquid part and Vf is the volume of liquid part. So it can be said that total volume of mixture is equal to V1. This is equal to volume of liquid plus volume of vapor. So total volume of mixture at point 1, basically it consists of liquid and vapor. So the total volume will be volume of liquid plus volume of vapor. As we know, a specific volume is equal to volume by mass. So in this condition, volume will be equal to specific volume into mass. So therefore, the volume of liquid is equal to a specific volume of fluid into mass of fluid, and this volume of vapor is equal to a specific volume of vapor into mass of vapor. Just put this value. Let's put this value in equation number. Let us say this equation number 1. Let us suppose this equation number set of equation number 2. So from equation number 1 and 2, we find that this is V1. Mostly this is the volume of mixture. What is the volume of mixture? This is equal to a specific volume of mixture into mass of mixture. This is equal to volume of mixture plus volume of gas. The volume of mixture will be equal to a specific volume of mixture into mass of specific volume of fluid into mass of fluid plus a specific volume of vapor into mass of vapor. So this will be a specific volume of mixture. Of course, this is specific volume at 1. This is equal to mass of liquid by mass of mixture into a specific volume of liquid plus mass of vapor divided mass of mixture into a specific volume of vapor. So finally, the specific volume of mixture may be written as mass of fluid. What is mass of mixture? Mass of fluid plus mass of vapor into a specific volume of fluid is equal to mass of vapor divided mass of fluid plus mass of vapor into a specific volume of vapor. We know this value is equal to x, right? So as we know, since x is equal to mass of vapor divided mass of liquid plus mass of vapor, so this implies 1 minus x is equal to 1 minus mass of vapor divided mass of liquid plus mass of vapor. This is equal to mass of liquid divided mass of liquid plus mass of vapor. In that condition, finally, if you put the value of 1 minus x and x, this value mf divided mf by mf plus mg is equal to 1 minus x. So this will be a specific volume mixture is equal to 1 minus x into a specific volume mixture plus x into a specific volume of vapor. This is equal to a specific volume fluid minus x a specific volume fluid plus x into a specific volume of vapor. If you arrange this equation, you will get a specific volume fluid plus, if you take x common, this specific volume of vapor minus specific volume of fluid. So this can be written specific fluid plus X, this is VFG. So in this finally we get a specific volume of mixture is equal to a specific volume of fluid plus X, a specific volume of VFG. This is our one property of this is the specific volume of mixture at point 1. Okay, so this is very important equation. Similarly, there's some different properties are also studied in this section because we are studying properties of substances. This is the one property of mixture in the sense, what is the sense of this mixture? This is the wet zone. This point 1 lies in wet zone. So different property is like specific internal energy. This is equal to U mixture. Of course, this is U1 is equal to specific internal energy plus fluid plus X into a specific UFG. Okay, where UFG is equal to UG minus UF. Okay, next property is a specific enthalpy. This is of mixture. This is H mixture is equal to HF plus HFG, right? Similarly, a specific entropy, this is S mixture, will be SF plus X SFG. So this is all about the properties of the substances at point 1. So finally, the conclusion of this discussion. This conclusion is as follows. This a specific volume of mixture is equal to a specific volume of fluid plus X VFG. A specific internal energy of mixture, this is equal to a specific internal energy of fluid into X into UFG. A specific enthalpy of mixture, it is equal to HF plus X HFG, and a specific entropy of mixture is equal to SF plus X SFG. These all are the properties of water vapor mixture at point 1, right? This is our conclusion. First conclusion, Next conclusion, we have find the dryness fraction x is equal to mass of vapor divided mass of liquid plus mass of vapor, where this Dryness fraction is lying between 0 to 1. This is very important. X is equal to 0 at saturated liquid curve, and x is equal to 1 at saturated vapor curve. So this is all about the distribution of right. So this is the where studies the properties of mixture at point 1, right? Thank you. We'll meet next session.